This video is part of the implementation action C3 of Project Life MycoRestore, and the title is Spread of hypovirulence for the control of chestnut blight. We are in the municipality of San Godenzo, in the Mugello area, province of Florence, a pilot demonstrative site of Life MycoRestore project. This is an area historically suited to the cultivation of chestnut since the Middle Age, especially for the fruit production. Here, in particular, we are in a chestnut coppice. Since the 50s, a dramatic outbreak of a new disease caused by an alien fungal pathogen has occurred, causing the death of many trees and loss of production. The disease, called chestnut blight, is caused by the fungus Cryphonectria parasitica, a pathogen native to East Asia. At the beginning of the 20th century, the fungus was introduced in the US and then, accidentally, arrived in Europe, exactly here in Italy, and rapidly spreading throughout the continent. But from the 70s in Italy, something naturally happened, and the situation began to change little by little. More superficial and less lethal anomalous cankers have appeared, and a typical strain of Cryphonectria parasitica, characterized by reduced virulence, have been isolated from these cankers. Subsequent analysis made it possible to discover that the hypovirulence agent is a virus that infects the fungus. This is the phenomenon of the so-called hypovirulence. In fact, as you can see, there are not much visible symptoms of the disease nowadays here, despite the pathogen is still present.
The important key of hypovirulence is that hypovirulent strain can transfer, can convert, can virulent one by sharing cell content. It means that some strains of the pathogen can meet each other through the so-called ethyl anastomosis. So ethyl that come in contact and can fuse can share the cell content, including the virus. The virus that transform the virulent strains in hypovirulent one. So this is a very possible, nice means of biological control and was well studied. But in the same area, normally there are several groups of the pathogens. Groups like independent groups that cannot share the cell content, that cannot fuse the ether that become in contact, and those groups are called vegetative compatibility groups. So that's why we have to select locally the hypovirulent strains, more than one, minimum 4, that could have high capacity to transform the virulent ones, that have a high capacity to transform as many different groups as possible, and that characteristic is called convertibility. The idea for the biological control of Cryphonectria parasitica is then to use the natural hypovirulence and inoculating many hypovirulent different strains with a high convertibility in a same area, we can improve, we can speed up the spread and development of the hypovirulence in a forest. And that's a good way for a biological control using unnatural mechanisms.
Hypovirulent strains of the pathogen, representing all the vegetative compatibility group identified in the area, were selected, cultivated separately in petri dishes, and then inoculated in several shoots throughout the forest. In the bark of suckers, we realized 4 wounds with a 1 centimeter diameter cork borer. Then, the cork borer is used to realize mycelium discs of the same size of the selected hypovirulent strains of the pathogen. The mycelium discs are separately inserted into the holes in the bark, covered with cotton wool to avoid the dehydration of the wound, and finally wrapped with parafilm. After approximately 1 month, the parafilm is removed. The hypovirulent strains begin to generate hypovirulent cankers, will produce spores, and naturally spread in the forest. Will become in contact with virulent strains of the pathogens and gradually will convert them in no little ones.